Good evening, everyone. Welcome to the sixth video on the IA discussions series. And day before yesterday, I think since 3 4 days we had been doing only on mechanics, and then we looked at something on thermal physics yesterday. On buoyancy, we looked at one more. Okay, and today we are looking at something related to fun games. Okay, why should every time we consider only the academic subjects? Why don't we do something which we do using fun, and how do we describe it using physics? Okay, so that's what is the interest here, and towards it, I have started with this. Let me share my screen. So problem number 6, and the question is, we all know how to play dominoes, and what variable does it affect the falling time of dominoes? You have a pack of dominoes, and you give a small push, automatically one after the other, one after the other. It's a chain effect, right? Domino effect we call. It falls off, and as a result of it, our interest would be to find out what is the total time taken by the dominoes to fall one by one, and what are the variables which affect this. So this is what we are interested into. Okay, now let us look at the possible type of questions that one can ask. The first one we can ask is, maybe depends upon the distance between the dominoes, right? Obviously, when the distance between the dominoes is very small, then it keeps on falling. Okay, that's what we think. Let us look at this also. Then height of the dominoes. If the dominoes height is much larger, then what can happen? Okay, so therefore, this question is possible. This question is also possible. Mass of the dominoes. Okay, mass of the dominoes. When the mass of these dominoes is very large, then what can happen is it will take a very long time to fall. Okay, so easily we can state, okay, this is what can happen. So this also is a possible question that we can ask. That means we have to take different masses of the domino sets, and then do we do with it. Thickness of the dominoes. So what happens when the thickness is very small, it will easily fall. When the thickness is much larger, it will be more stable. So it's not possible to make the dominoes to fall. Then the angle of tilt. Okay, the first one, the moment you tilt it across, okay, by what angle will this one tilt, right? So this angle I'm talking about. You see, this is one line like this, and this is a straight line like this. What is this angle? If this angle is much larger, then it's very easy to make it fall. If it's much smaller, then quite difficult. But on the other hand, if the domino is like this, and if you make it to fall like this, okay, if the first domino falls like this, the second domino is standing like this over here, then what can happen? You see, the angle is much larger over here, but the domino may fall like this, or it may fall like this also, right? So it can happen, anything can happen. So this is a big question over here. It's a very good question to be asked about. Then external force on the first domino. What is the force acting on the first domino? If the force is larger, then all the dominoes will flip off and fall off, okay, at a much faster pace. If the force is much lesser, then definitely it may not fall. It may take a longer time to fall, right? So therefore, so it also depends on this. So it's idea number 6. Okay, so we have seen 6 ideas. Let us see, do we have some more? Yes, do we have some more? So the number of dominoes. Okay, in a pack, if I have large number of dominoes, then definitely, okay, it take the force taken by it will transmit to the other one, and it falls over here. So whether it depends on it, or does it take the same amount of time, that we do not know. We can look into this also. Then domino material. Okay, let us say, for example, if it is made out of a light material like a plastic, then how fast does it fall? Maybe wood, how fast does it fall? Maybe metal. Okay, so what is the speed? You can think about all this also here. Coefficient of friction. If the friction here is much larger, then what can happen? Okay, it will just pose it like this. It will not be able to rotate it. It will not be able to fall. So therefore, it also depends on this. Then type of the triggering force. Are you triggering it by a hand? Are you triggering it by something like taking this pen and hitting it like this? Or are you taking something like a spring and then hitting it across? What is it you are trying to do it? It also depends upon this. So therefore, there are 10 different factors. All the factors are equally valuable. Okay. So therefore, we need to actually look into how do you truncate that, what is that you are going to do. So every factor is good enough. Okay, now let me revisit these factors once again. So usually what we do in the previous videos that you have seen, okay, after this video, we look at this one here. How would you narrow down these ideas? Okay, here also let us look at this. Length, thickness, distance, all this can be measured using your measuring tape or maybe a scale, a ruler, whatever it is. So you don't have any problem in doing experiments or taking variables related to this. Mass of the domino, weighing machine is available, so therefore still you can do with this. Angle of tilt by protractor, time of fall by timer. Okay, now let me go back to these ideas and see which of them cannot be using this one here or will not be using this one. Distance between dominoes, you can do it, you can use it using a tape, measuring tape or a ruler. Height of the dominoes, again a tape. Mass of the dominoes, weighing machine. So this is also okay. Thickness and dominoes using a tape, okay, or maybe you can use something like your vernier calipers. Angle of built, protractor, so this is also possible. External force on first domino, how do you solve this? Okay, this is a headache now. So this I do not have any measurement to start with, so therefore I will not be using this one. So it's quite difficult. I can do it, but it's quite difficult. I don't have any idea about to begin with. See, the ones which you do not have an instrument to work with, do not attempt it. Okay, maybe if you still want to do research, it will take a long time. You have to decide whether this will work or not. You need to calibrate it. You have lots of questions over there. So it's better that, okay, what is available in hand, proceed with it. What is not available in hand, don't even attempt it. Okay, let me go on to the next one. Number of dominoes, you can do it. Domino material, you can purchase dominoes starting from wood, or maybe you can go for iron, or maybe you can take plastic. You can do whatever you want. But the problem is, how do you quantify it? That's the question. Here also, you see number of dominoes. You can put 50 dominoes. Okay. Then maybe if you put 51 dominoes, 55 dominoes, 70 dominoes, you can put any number of dominoes. You can do it. But domino material, how do you quantify it? Here you quantify it by a number. I always say your independent variable here should always be having an unit. Okay. But here it has a number over here. I don't think, okay, this is a good one. So I will not go for this also. The next one is domino material. Domino material, again, you have wood, iron, plastic, and so on. But how do you quantify it? Maybe based on density. Density will not be uniform. And you need to have 7 observations. How do you go with it? So it's not so easy to do with it. So I am not going to do with this also. Coefficient of friction. Do you really know what is the coefficient of friction between one surface and the other one? You need to do a separate experiment for that. So I won't go for this also. Okay. Type of targeting force. What is the type of targeting force? If I say I am using this pen to hit a domino, then how do you measure this? Can you measure, hey, I hit it like this? Can I write something on the tableau column? No, I can't write. So therefore, there is no point in going for this also. So how many ideas are left out now? So 5 ideas are gone, and I have only these 5 ideas. So which all depends on this one. So for all these 5 ideas also, I can use any one of them over here. Now how do I narrow down? I should use something here, right? Okay, now first one is length of the domino. Length of the domino. Now you see, now how do you change the length? For example, I take one set of dominoes whose length is something like around 5 centimeters. 5 centimeter height. Sorry, 5 centimeter height. Okay, the next one I'll take a set of dominoes with 6 centimeter height, 7 centimeter height, and so on. Okay, see, I may be having at home one set of dominoes which are all 5 centimeter height. Do I have 5 centimeter, 6 centimeter, 7 centimeter? I need to have something like around 7 observations, and all of them should vary only with 1 centimeter difference only. Can I get this much set of dominoes? This is the question over here. Or maybe you need to design it. So it's again a cumbersome thing, right? Okay, so if there is something available easier, you proceed with that one. Why do you want to take something which is very complex? So therefore, I am not going to go with the length or height of the domino. Thickness of the domino, again the same problem, right? Thickness, okay, should vary, okay, systematically. Let us say the first thickness could be something like 1 centimeter. Second one could be 1.2 centimeter, 1.4 centimeter. Can I get dominoes which are varying thicknesses like this? Very difficult to find. So therefore, this is also not possible for me. Length is not possible. Thickness is not possible. Okay. When nothing is available, I can try doing something. Okay. But okay, when something is available, why do you want to do it? Then distance between the dominoes. So what I can do is I can take a set of dominoes, 50 dominoes, for example, I can take. Okay. And then I can vary the distance. I can keep it over here. And I can say initially I am keeping it at something like 0.5 centimeter. Okay. Then so this is also 0.5 centimeter. I'm going to push this, okay, and as a result of it, dominoes fall on each of them, and then find out what is the time taken by all the 50 dominoes to fall. I can do this. Then what I can do is I can increase this distance to 0.6 centimeter. I'm not meddling or I'm not tampering with the domino. I'm just keeping the domino aside, right? One domino, you keep it here. Second domino, you keep it beside. Okay, then you keep on increasing the distance. So this is a good measure for me to begin with, right? I can always go with it. Mass of domino. Once again, same problem, like length, like width, and so on. How do you change the mass of the domino? I don't have anything. You can weight, no issue. But the problem is I want to weight systematically. Okay, I want to change the masses systematically. If the first domino is of the weight, something like 1.2 grams, second one should be 1.4. For example, recently I bought a set of dominoes. Okay, I found out that each domino does not weigh the same. Though I brought it from the same company, okay, one domino weighs 1.2 grams, other one weighs 1.25 grams, other one weighs 1.4 grams, right? The thickness of the domino will start varying, density starts varying. So therefore, this also is not a good one to go with, right? I don't recommend anybody to go with this one. At least these things you can do something, but this one I definitely don't recommend. Though weighing machine is available, but still you may not get the correct value. Angle of tilt. Okay, now how do you start with the angle of tilt? Now, let us say, for example, I have kept a domino here like this. I kept one more domino here. Okay, now I should make the angle of tilt like this. I should make the angle of tilt like this. Will I be able to make it stand like this slantingly? Okay, I should put some support over here and do it. Not so easy, right? I can have it protracted to measure, but still, okay, this is not a feasible one. So I'm not going for this also. Time of fall. Okay, then what is that we have seen? Now let us go back to this distance between domino. We are going to do this one here. We are going to do this one here. Height is not possible, mass is not possible, thickness is not possible, angle of tilt is not possible. The rest of them are already possible. So what we have done is we have finally come to an final conclusion saying that how does the distance between the dominoes affect the falling time of dominoes? We come to a good hypothesis over here. Now the next question is that, so how are we going to keep the dominoes? I am going to keep the dominoes like this. One here, one here, one here, and so on. I'll show you one more arrangement. Think about it, whether this will affect or not. This will work or not. The same domino I kept here. I'm keeping it over here. What does happen? Do you think this will happen? This will work? No, because the moment you give any kind of push over here, it is not going to slide. This is going to rotate and fall here. If it falls here, does it touch this one? It doesn't touch. So therefore, the first domino will fall, second domino will not even be touched. So as a result of it, nothing will fall, right? Which means that the first thing that you need to look at is that find out what is the height of the domino. Height of the domino. Let us say height of the domino that you have got here is seen to be, let us say for example, it is 5 centimeter. Then where should the other domino be kept? This point should at least touch this point over here. Okay, make a measure. Okay, something like 3/4 of it should be measured, or maybe half of it should be measured. I already told you, no, because if it comes and touches here, there's a possibility that this domino will fall like this over here, right? You have this pen over here. If you apply a force here at the top, it will tilt like this. But you have the pen like this, you apply a force here. What happens? You are applying a force here, this may tilt like this. If it falls towards you, then there's no point in using the domino because it will not affect the next one, right? So therefore, it should at least touch, not at the middle, maybe a little bit away from the middle, which means that if your height is 5 centimeter, it should be able to touch at least a 2.5 centimeter, 2.5 centimeter, which means what? If this is my domino over here, the first distance or the maximum distance that I can keep is only 2.5 centimeter. 2.5 centimeter, so that this will come and touch like this. This will come touch here at the middle, and this should be at least 2.5 centimeter. Okay, if it is more than 2.5 centimeter, it is unpredictable. You cannot say anything. If it is less than 2.5 centimeter, you can guarantee saying that okay, it will work. So from 2.5 centimeter, we're going to work backwards. Okay, so how are you going to work backwards? You're going to say first you are going to find 2.5, 2.4, 2.3, 2.2, 2.1, 2.0, 1, 2, 3, 4, 5, 6, 1.9. Okay, you're going to take all these readings, right? And as a result of you are going to work with this. Okay. So thus we have looked at almost all the variables, and the variable that we have considered is the distance between the dominoes. And also we see that the important thing that when we consider distance between domino is that okay, this constraint should be taken care of, right? So therefore, if the height of domino is 5 centimeter, then the domino should hit at least the next domino at a height of 2.5 centimeter. Only then you can expect the dominoes will start falling, or the minimum distance between them should be Okay, 1.9, and then it should vary from 1.9 to 2.5. So what is that we are doing? We started with an experiment, we decided about hypothesis, and finally we have come to understanding what are our variables. Okay, very important thing in your IA is not about designing an RQ or completing your IA, okay, or doing an experimentation. Before experimentation, 50% of your experimentation depends upon how you decide your RQ, what is that you are going to look into it, what are the variables, how are you going to vary. So all this becomes very, very important. Once you have designed all this, your design of experiment is ready, then comes the rest of them. It becomes quite easier for you. Okay, so finally we are formulating the hypothesis. If the distance between the domino increases, the time of fall in a pack of dominoes also increases. Okay, now you have to give the reason why does it happen, because as it hits over here, the end that we have over here, the dominoes end that we have over here, it takes a longer distance to fall, okay, and hits it, and as a result of it, first time it might hit here, second time might be if I increase the distance to here. If I increase the distance to here, this might come and hit here. See, this distance, this height is now differing, and as a result of this, definitely the time of fall will increase. Okay, so now we have formulated the hypothesis. Next, how do you make the dominoes fall? The next question. It's quite easier here. Nothing but okay. You just touch a domino to fall. How do you quantify it? Every time when you touch it, are you going to touch in the similar way? Okay, or is there any method to do it? Right. So as I told you already, you can take a pen and then hit it across. Okay, but I may hit it every time in a different way, right? So the time of fall will also change. So how do you account for this? So what you need to do in this case is that you need to have a constant force acting on these dominoes. Okay, how do you make a constant force? The simple thing is that I always follow like this over here. I take something like a stand here and then keep the table here, or maybe this is the floor, and then put an inclined plane here. Put an inclined plane over here, and then like this, and then I keep the dominoes over here. I keep the dominoes over here. And I put an object. Let us say, for example, I can put a marble. Now what can happen? When the marble starts rolling like this, it comes here, it comes to the edge, and then it starts rolling here. Maybe it can bump here, it can roll here, and you hit here. Do you think this will work? This will not work. Because there is a possibility the first one will hit. Okay, but maybe it may not hit. And if it hits over here, if the marble hits here, there's a possibility that this domino will fall like this. It will not affect the second one, right? And the rest of the dominoes will not even fall over here. So what is that you do? So this diagram is incorrect. So what is that you need to do? You need to do a diagram like this. You need to keep the arrangement like this over here. So keep the inclined plane like this. Keep the inclined plane like this. Okay. So what is that I did for an inclined plane? I put a hollow cylinder or maybe a pipe, a PVC pipe or maybe a wooden pipe. Okay, or whatever you have at home. Okay, or in your place in your school, you can use this. And then you keep the first domino here. Keep the first domino here, so that this comes here directly. It comes and hits here. The moment it hits here, this automatically starts falling like this. Okay, and hits the second domino, and thus this keeps on happening. Now it works over here, and the force that acts at this point will always be a constant. Why should it be a constant? If you ask me, the reason is because I need to keep a stand here also. I need to keep a stand, two stands I need to keep. I need to adjust them in such a way, or maybe books I can keep it, adjust them in such a way that it comes and falls over here. Okay, why the force is constant? The reason is because, so if this is my angle theta, this is my angle theta over here, and you have the marble inside this one here, okay, then the force acting on this marble would be equal to, if this is your mass, the m into g, this should be equal to mg sine theta. And this mg sine theta will not vary, because the reason is m is constant, g is constant, theta is also a constant. You are not going to change this apparatus, this angle. Okay, and as a result of this, you can see the dominoes can fall. Now, in one of the questions, in one of the examples that we have seen, I had asked about how do you change the force over here? What is the method you are going to change? So that can be understood from here or realized from here. When I change the value of theta, then automatically force will change. Maybe in that case, I can choose theta to become an independent variable, right? Okay, so this starts falling like this. This starts falling like this. Okay, and as a result of this, okay, the time of fall can change. Okay, so now we have understood how to create a force which is constant, which hits the pack of dominoes, the first card of dominoes, and makes the domino subsequently fall. Okay, we have now come to a what you call a reasonable answer for each and every question that we had. Okay, now let me move on. Identifying the variables. After you finish the hypothesis, identify the variables. What is it? Independent variable is distance between the dominoes. Dependent variable is time of fall, right? And then controlled variable. Time of fall doesn't mean it's a time of fall between one domino and the second one. It's a total time of fall. I should mention it over here. Okay, this is total time of fall in seconds. And when you write about independent variable, you should mention clearly distance between domino. What is the range? Okay, the range is nothing but I said 1.9 to 2.5 centimeter. And how are you varying? 0.1 centimeter. Okay, so all these three factors are very, very essential to describe what is your independent variable. Your dependent variable is measured in seconds. Then controlled variable, type of domino, thickness of the domino, area of the domino. Then you have number of dominoes. What else can you think about? Okay, the place, position of force. Position of force acting on the domino. Acting on the domino. So everything becomes important, right? We have to measure all this. Is there anything else that you need to control or measure? You need to make a list of all the parameters and put it. Okay, do not mention only 2 or 3 parameters because, okay, we need to look at everything over here, right? Next, key formula. If there is a key formula available, then definitely you can write it. See, I have shown you some pictures over here, images over here, whichever question I am talking about. See, distance between in inches and time taken in seconds is falling dominoes. What is this about? This already someone has done an experiment based on this. Okay, so as a result of this, this graph is available, which means some math should also be available. You can ask me, should I redo the same thing? Now it's left to you. Okay, I have just given you the clues. Okay, and if you want to do the same thing, you do it, or you want to change the angle, you do it. Okay, see what that fellow has done, and if he has done something new, okay, as if he has done something and you want to change something, you can change it, right? And then look at the graphs, plot a graph of dependent versus the independent variables, and then think how do the formulas connect between each other, draw relevant diagrams, do all this. Okay, it should be like a science article. There are some students who do something like, okay, they describe an IA, but there is no picture or image of the IA. Okay, the experimental setup. They write about everything, but unfortunately, the image is not there. If the image is not there, how do I understand that you have done the experiment? I don't want your picture, you standing there and doing the experiment. I just need at least need to know, okay, how you are done, what is the experimental apparatus you use, right? Without that, then the IA is useless. That's what I always consider. Okay, next. Apparatus and setup. Where do you get this apparatus? Where do you buy it and so on? You can buy everything from Amazon, as I told you. So you have a pack of the dominoes. You get it at a much cheaper price at 210 rupees. It's the cheapest one. You can buy any one of them. Okay, there's nothing like good quality, bad quality, and so on. You are going to conduct an experiment. You are going to do it in an appropriate way, correct way. Okay, so that's what. So therefore, you can choose any one of them, and then you need to have one marble. Okay, you have 10 or 15 marbles. 50 marbles you get it over here. Okay, if you have a marble at home, then it's fine. Okay, don't use something like which is a sliding object or something to minimize the cost. Okay, do buy a marble and then use something like pipe. If you have a PVC pipe, okay, the old one, then you can use this, or otherwise you can also buy it from here. So you get this one here. I'm not a what do you call an Amazon affiliate or anything to recommend, but okay, I generally find these things and put it across, so it will be useful for you. Okay, next, data collection. Now this is an example. GIF format is showing something like of different heights, right? See, so okay, it's a wonderful thing that people have done. Okay, so now pertaining to our data experiment, you see the distance between the dominoes was kept at 5 centimeter, time of fall is 10 seconds, and if it is 6 centimeter, 12 seconds, and so on. So this is what we require. But you need to do at least something like 3 to 5 trials and 7 observations. When you do this, it's fine. So you should have one independent variable, one dependent variable. Independent variable is fixed. Use uncertainties. Dependent variables should be, okay, at least only one variable. It should be only one variable, but it should have at least 3 to 5 trials. More the number of trials, it's always better. Okay, you can reduce the random error and you can always look for the outlier analysis. You will be having something to write in your evaluation. Don't do something like only one trial. This will never help you out of it. Okay, so do it at least for 3 trials. 3 to 5 trials is always recommended. Right. Let me move on to the next one. Now, finally, we have collected the data, we have analyzed it, we put the graphs over here, and then we come to evaluation. Evaluation, as usual, the last two slides will be the same, but only thing is it will be relevant to the given experiment. So, what is that we have? Sources of uncertainty and error. So, what is that you need to mention? You need to look at what is the reaction time error. See, whenever there is a concept of something like finding out the time of fall, when you start the timepiece, that is your clock or your mobile or whatever it is, you will have something like zero point 0.3 seconds as a human error. When you stop it, again 0.3 seconds. So 0.6 seconds goes as error, definitely. Okay. And if you are not so strong enough, that is, if you are not very certain enough, then the reaction time error would be much more larger also. Okay. And then misalignment of dominoes. So who knows that when you put a domino, say for example, I put one domino here, the other domino, I may put it a little bit away. What do I mean to say is in 3 dimension, I'll put one domino here, one domino a little bit away. So it's like this over here, a little bit away over here. So as a result of this might only come and touch it over here. There's a possibility that this can fall or not. So that can also happen. Misalignment of dominoes can happen. Air currents. While you are conducting the experiment, let us say you put on the fan. Then what can happen? Even a slight touch of it, okay, might make it to fall faster, right? So that is also possible. Inconsistencies in domino spacing. So while you place it across, you have to be very careful, you keep it properly, you try to do it. But still, there could be a possibility that you will miss the distance by maybe around 1 millimeter. If you miss by 1 millimeter, because every distance that you are going to do is something like you are starting with 1.9 centimeter, which is nothing but 19 millimeter. 19 millimeter. Next one could be 20 millimeter should be your radius, should be your distance. Okay, but when you keep it at 19 millimeter, if you accidentally keep this at 19.2 millimeter, 19.2 millimeter, that means you are closer to it and you are making a mistake. Okay, so inconsistencies in domino spacing, this will happen in your experiment. So as a result of it, your experiment may introduce some errors or it may go wrong. Limitations of the method. Manual placement will introduce errors. That is always there, so you cannot do anything. And then dominoes may not fall straight. So when you apply a force, there's a possibility that this domino surface that you have over here, okay, may not be exactly uniform. So it might tilt like this. When it tilts like this and falls, then what can happen is the force at which it falls on second one will vary. See, because our experiment completely relies on the fact that the force is uniform only. If the forces are different acting on every domino, then definitely your time of fall will not be a constant, will definitely vary. Suggestions for improvement. What is that you are going to do? You are going to use a tracker software. Okay, you are going to do a video analysis. That's always good enough. Number of trials. So don't do 3 trials. IB recommends only 3 trials is fine. Do 7 trials. Who stops you? Right? Do 7 trials, or 8 trials, or 10 trials. And if there is an outlier analysis, outliers, remove all those and then take the average. Because the time differences that you get here would be of the very, very small value. Okay, so therefore, do more number of trials and try to get a consistent values. No fans. I'm using my fan to work here. Okay, but definitely when you are doing an experiment, do not use fans, especially of these kinds of things. Right. Then finally, such strength of your conclusion. So first thing is, even though you get a different values, now what is that you mentioned? You mentioned that, okay, as the distances increases, the time of fall will also increase, right? So therefore, the trend should be seen over here. Don't worry about what is the value you are getting. The trend should be seen. If that is the case, then definitely the strength of your conclusion is there. Does it fit the theory? Okay. So there should be some equation between these two parameters. Someone would have done it. Look for the research articles. Okay. Mainly look for the research articles. Most of them don't do it. They just think, okay, and IA is nothing but you are conducting an experiment and you are going to stop it there. That is not correct. So look for the research article, very, very important, and look for the equations there, the math there. If you are able to arrive at the math yourself, it's well and fine. If not, you look for the articles which people have already done there. Okay, cite that article. Just don't copy the math from here. Cite that article and say this is what they have done, and as a result of it, you take the values, the data that you have, map it with it, and see how well this maps it. Right. Then the precision here is limited due to uncertainties. You also mentioned, okay, how does the uncertainty play a role in this? So we need to look into all of them. Lastly, so how does your, just a minute, yeah. So you should look for a clear and direct answer to the RQ. Okay. Do you get a clear answer to the RQ? Then you look at the interpretation of the processed data. What is the process data you get? Okay, process data will show you shorter distances, longer distances. What is that you get? How is the distance related to time? So you get an answer from there directly. Do a comparison from the data. Reference to associated uncertainties. So uncertainties would be there in every experiment. Okay, if you do not write an uncertainty, that means it's your mistake. You are going to lose a mark there. Okay, so therefore, do mention the uncertainties in every experiment. Uncertainties will definitely affect the slope and it will not affect the trend. Then you link it to the scientific theory. There's an accepted model which we have already followed. There's one thing called as a domino propagation wave model. With respect to this, I'm talking to you. Okay, but if you are doing an experiment, there could be a similar wave model. There should be a similar model which people have already worked on it. Okay, we are always going from knowns to unknowns. Okay, so therefore, so look into that model, how well that maps with your model, with your experiment. Look into it and mention it. Source the citation that is traceable. Very, very, very important. Okay, so most of them, what they do is they use ChatGPT, take up the RQ, put it there, and ask for give me all the citations, 10 citations. Now ChatGPT will give you something. Okay, so then you will take up all those and put it across. But out of curiosity, if you take up these citations and search it across the web, you will find 70 or 80% of the citations will not even exist. Okay, it just hallucinates and gives something else. So do not do it. Okay, there's a possibility that 100% of the time you will not get it. Okay, the name might be very similar. It will search for the web, but it doesn't actually grab that particular citation, put it across. So therefore, don't do it. Right. So this, okay, so you have to look for citation and read the article, understand what does it say, does it map with this one. Actually speaking, okay, you should first do a research review, and after that only you should start your experiment. Okay, but most of them, what they do is they conduct the experiment, they get the data, they try to cook in the data here and there, get a graph and see to it that the graph is always linear. Okay, that is completely wrong. It need not be linear every time. It can be non-linear. Okay, and finally, okay, look for the citations. They look whether this particular article has this one. In fact, they don't even look at it. They just give it to ChatGPT and finally get the answer, which is completely incorrect. Statement about how the consistent with the data is the scientific context. Okay, so how consistent are you working with? So look into all this. Okay, so thus with this we come to an end to this particular experiment. And if you really like this video, do like, share, comment, and subscribe to my channel for more updates. So I think from next Monday onwards, we'll be starting once again the new problems in IB physics, some related to MCQ or structured paper. I'll be putting it. Thank you. Thank you once again.